Dimensional Analysis Video Notes, Part 2.
Well, it's about time.
Problem number 3. How many seconds are there in 10 years? Note, do not count leap year's date of February 29th. And actually, we rarely ever count leap year's date of February 29th. So anytime you're doing a problem and it asks you how many seconds or minutes or a certain amount of time there is in a number of years, don't worry about leap year. First step when doing this problem is identifying the units or rates that's given to us in the problem. So seconds is given, that's what they want, and 10 years it's given to us also. So I'm going to draw my conversion table. I'm going to start at 10 years. And I'm going to want my answer to be in seconds. So here's my start and my finish, or my end. So when I'm going from years all the way to seconds, I have to figure out what conversion ratios I want to use in between. We don't want to use weeks because there aren't actually 52 weeks in a year, contrary to popular belief. It's actually a decimal. We don't want to use months because if we go from years to months, then we'd have to go from months to days, and every month doesn't have the same amount of days in it. So we can't use months or weeks in this case. So why don't we just go straight to days? So I'm going to put 1 year on bottom and 365 days on top. So by using that conversion ratio, I can already cancel out years. So now I have days left, but I want seconds. So from days to seconds, I have to go through another conversion ratio. Well, we know that there are 24 hours in one day. So I'm going to use 24 hours in one day as my second conversion ratio. Then I can cancel out the days. So now I have hours and I'm going to seconds. So to get from hours to seconds, I have to go through minutes. We know that there is 60 minutes in every 1 hour, or there are 60 minutes in every 1 hour. So now I can cancel out hours. And for my last conversion ratio, I'm going to use the ratio for minutes to seconds, which is 1 minute for every 60 seconds. So now minutes cancels out, and I'm left over with just seconds, which is what I wanted in the first place. And for my last step, I will multiply by all the numbers on top, 10, 365, 24, 60, and 60. Multiply all those together and divide by all the ones on bottom. And I should get 315,360,000 seconds. And that is my answer.
Yeah, I came down here to see Junta because he told me to come down here because I'm his half brother from Beijing. Me and him got the same mama. I'm Blackanese.
Problem number 4 says that Jackie Chan lives in Beijing, China, and Chris Tucker lives in Atlanta, Georgia. Chris is planning to surprise Jackie by visiting him in China. The private jet that he is riding in travels at an average speed of 900 kilometers per hour. How long will it take for him to arrive in Beijing if the distance from Atlanta to Beijing is 7,173 miles? So for my first step, I've already identified all the units and rates in the problem that are important. Notice in this problem, it gives us 2 rates. The first rate it gives us is 900 kilometers per hour. The second rate is 1.609 kilometers equals 1 mile, or per 1 mile. The only unit it gives us by itself is 7,173 miles. It's kind of my rule to just start with the singular unit. So that's where I'm going to start at. It usually works out better in the end. Then for my next conversion ratio, I'm going to look for the conversion ratio that actually has miles in it because I want to cancel out miles on top and on bottom. So I put 1.609 kilometers on top, 1 mile on bottom, and the miles will cancel out. Now I'm left with kilometers. So now I'm going to use my only rate left, which is 900 kilometers per hour. So that's the same thing as 900 kilometers per 1 hour. Notice I put kilometers on bottom because I still want to cancel them out so that I only have hours left. So hour. And this is such a beautiful problem. This is the first problem that we've actually had a whole number on bottom besides 1. So in this case, we're going to multiply 7,173 times 1.609 times 1, divide that by 1 and 900, and we should get approximately 12.824 hours.
Do you understand the words that are coming out of my mouth?
I'm not going to read every problem to you. It takes up too much time on the video, but this is normally where you would pause the video and read the problem for yourself.
Did you hear I finally graduated?
Yeah, just a shade under a decade, too. All right.
You know, a lot of people go to college for 7 years.
I know. They're called doctors.
In this particular problem about doctors, it doesn't ask us to convert to any certain unit. It just asks us which doctor spends more time working. So really we can convert to whatever unit we choose. What we need to do is convert all of these 3 units to the same unit. So we could convert them all to seconds, all to minutes, or all to hours. I'm going to choose minutes because minutes is in the middle, so I'll only have to convert 2 one time. But you can pretty much do it however you like. So I'm going to start off with Dr. Harold. Dr. Harold works an average of 9 hours per day. So to convert that to minutes, I would use my conversion ratio from hours to minutes. And so I would have eventually 9 times 60, which would give me a total of 540 minutes that Dr. Harold works per day. Dr. Wilson's is already given in minutes in the problem, so I don't have to convert it to anything else. He works for 700 minutes a day on average. Dr. Patel's math comes out to be 666.6 repeating minutes per day. So it turns out that Dr. Wilson is the one who actually works the most. And that's interesting because he's actually the one pictured right there from the TV show House. The important rates have been identified, 4 miles per hour, and we're going towards feet per second. Remember that 4 miles per hour actually means that 4 miles per 1 hour. And we want our answer to be in feet per second. Remember that per in dimensional analysis problems usually means divide. So we have feet on top, second on bottom, feet per second. So if we just look at our distance units here, miles and feet, we know we're going to have to convert between the two. So we're going to need a conversion from miles to feet. If we look at our time units, hour and second, we're going to have to convert through them, which means we're going to have to go through minutes. I've listed all the 3 conversion ratios that we need at the bottom. So I guess I'm going to go ahead and start plugging them into the table. I'll start off with miles because miles is on top. I want mile on bottom. So there's 1 mile on bottom. And there's 5280 feet on top. So now we can cancel out miles. So now actually in our conversion table we have feet per hour. We're needing feet per second. So we need to convert hours to second and we'll be done. But to convert hours to second we have to go through minutes. So I'll put 1 hour on top, 60 minutes on bottom. Now I can cancel out hours on top and on bottom. So that now my conversion table actually has feet per minute and I'm looking for feet per second. So now I have my conversion table set up the way that it needs to be. I have all my units canceling out except for feet on top and seconds on bottom as indicated by the white circles. And now I can just multiply everything on top and divide by everything on bottom and get my answer. So 4 times 5280 divided by 60 divided by 60. So my final answer is 5.86 repeating feet per second.